Hey guys, okay, let's get started on our Unit 3 study guide. I'm going to see if I can autofocus here, and we're just going to write the powers. Rules, anything to the 0 is just going to be 1. Negative exponents, it's going to flip, so it's going to be 1 over x to the a. And yes, that is an a. Let me pull up here and see if this can get a little bit better of an image. Oops, right in that a little bit. Okay, so a product rule is going to be you will add your exponents, so x to the a plus b. Power rule, when it's raised to another power, you're going to actually multiply a times b. And when it's written as a fraction, or a division, you're going to think you need to subtract. I sometimes say, think of this as a giant subtraction sign, the dividend. So x, a minus b. Right, so this is the product rule, which means we're going to add them. And it's going to be x, 10 plus 19, which is going to be x to the 29th power. All right, in this case, we're going to look and see what we have here. Well, negative 18 will stay where it is. This x to the negative 5th, that's going to have to come down below because it's negative, so to make it positive it has to move. Y to the 0 just becomes 1, so we don't really need to write times 1. And then w to the 6th, there's nothing to simplify it with, so it just stays like that. All right, next up, we're going to think subtracting our exponents. So x to the 7th minus 15, well, that's going to be x equals, or x to the negative 8, but that has to move to the bottom because we can't have a negative exponent, so x to the 8th. Moving right along, we're just going to do 1 over 3 to the 4 to eliminate the exponent, and we're going to actually raise 3 to the 4th power, so we're going to have 3 over 81. Here, we've got to distribute this 2 exponent to every term in here, so to the 5, the a, the b, and the c. Well, 5 squared is 25. 7 times 2 is 14, so a to the 14th. b to the 2nd times 2 is going to be b to the 4th. And c to the 3rd is going to become c to the 6th, right, because we multiply. Now, this time there's a multiplication sign separating them. So I'm going to do my coefficients first, which is going to be negative 24. And my x's I'm going to add. So x to the 9th, and then y to the 4th. Okay, here we go again. All right, 16 over 4, you're going to simplify your coefficients, and that's going to give you 4. X to the 5th, and remember we're subtracting our exponents, so x to the 2nd. And y, it's going to be 2 minus 7, which means that y, because it would be a negative, is going to have to stay down here. Right, moving along, negative exponents, all we need to do here is just reverse them. So w to the 4th comes to the top, and v to the 3rd moves to the bottom. Oops, I forgot to box that answer if we're looking for consistency. All right, this 2 exponent, it distributes to the 4, the 3, the 5, and the y. And rather than worry about it being raised to a negative, I'm simply just going to swap their places. So I don't even have to worry about the negative exponent. I'm going to move that up and bring it to the 2nd power. 4 squared and x to the 6th. All right, now I'm actually going to simplify my coefficients. So 25 y squared over 16 x to the 6th. Okay, if we're looking at these, you can see that it adds 3 each time. So that would be an arithmetic sequence. And our next terms would be 14 and 17. Here, hopefully you can see that it's multiplying by 2 each time. And that would make our next terms negative 48 and negative 96. And because it's multiplying, that's a multiplication sign, that would be geometric. All right, over here, it is dividing by 2 or multiplying by 1/2 each time, which would make this next term 5 and this next term 2.5. Because it's multiplying, geometric. And here, it's actually adding 5 because even though it goes from negative 50 to negative 45, the number is actually getting bigger, right? Because it's becoming less and less negative. So plus 5. Now guys, hopefully this continues to record because earlier I just got cut off, which is such a bummer. Okay, so what we want to look at is what's happening from each term, and hopefully you see that it's multiplying by 2 each time, which means to find our 0 value, we have to divide it by 2. So 30 divided by 2 is going to give us 15. That is going to be our 0 spot. All right, my common ratio is what I multiplied it by to get from each term to the next, and in that case, that is 2. So my equation then looks like this: y equals my initial value, my 0 spot, 15, times 2 to the x. All right, let's try it again. What's happening from 54 to 18, from 18 to 6, 6 to 2? Those smaller numbers might be easier for you to identify. So 1 over 3, 1 over 3, it's being divided by 3 each time. So to find our 0 value, we're going to do 54 and multiply it by 3, and we're going to get 162. So our initial value, our 0 spot, is 162. This is also going to be our y-intercept, which we'll see in a minute. Our common ratio is 1/3, and our equation is going to be y equals 162 times 1/3 to the x. All right, same thing down here. We're going to look and see what's happening each time. Oh, it's getting bigger and bigger. So I can see that this is being multiplied by 4 each time. So my common ratio is 4. My 0 spot, I'm going to divide 12 by 4. I'm going to work backwards. I'm going to get 3. So I know that my equation is y equals my initial value, 3, times 4 to the x. All right, what does it look like happening here each time? It looks like to me that they're dividing by 4 or multiplying by 1/4. So to get my initial value, I'll do 32 times 1/4. Times 4, 32 times 4, and I'll get 128 for my initial value. Ooh, that's a big one. My common ratio is 1/4. My equation is y equals 128 times 1/4 to the x. Well, this one's pretty nice because they give us our 0 spot, right? So I'm going to have y equals 4, my 0 spot, 0, 4, which basically is my y-intercept, right? And then I'm going to look to see what they were doing each time to get to the next value. And in this case, they're multiplying by 3. So y equals 4 times 3 to the x. Again, they're so nice and they gave us our 0 spot. So y equals 625. And we need to figure out what our common ratio is. And I don't know if you can see it. It might be easier when you get down here. But they are basically multiplying it by 1/5. And that is to the x. All right, here we don't have our 0 spot, so we need to figure out what that is. All right. So we go from 20 to 80. to 320 to 1280. Huh, to me it looks like they're multiplying by 4 each time. So my common ratio is 4. Now let's find my 0 spot. I'll do 20 and I'll divide it by 4 and I'll get 5. So my 0 spot is 5. Okay, determine whether each function represents exponential growth or decay. We just look for our initial value, or y, we look for our common ratio. If it is greater than 1, then it is growth. If it's less than 1, like 1/4 is, then it's decay. So common ratio is less than 1. And now I'm just going to call it CR for the next few. So CR, well, 5/4, ooh, that's greater than 1. So it's growth, and our common ratio is greater than 1. 4/3, ooh, also greater than 1, so it's growth. Common ratio is greater than 1. 1/2, ooh, less than 1. Common ratio is less than 1. 7/3, ooh, bigger than 1. Common ratio is greater than 1. Okay. Next page. Hopefully this is clicking for you guys. All right, we're going to find the nice points. All right, we're going to look where it exactly crosses some grid boxes. And we're going to see that that is -1 for our x with the point 1. We're going to see that that's 0 for our x and a +2. And we're going to see that's 1 for our x and a 4. So the y-intercept, which is right here, oh guys, that's our initial value, our y-intercept, initial value. It's 2. Our common ratio, hopefully you guys can see that each time it's been multiplied by 2. So our equation would be y equals 2, parentheses, 2 to the x. Initial value, aka y-intercept, common ratio, whatever term we're raising it to. All right, we're finding nice spots again. And here we start with 0, it's a 1. We have a -1, and it is, why can't I speak? 2, and we have a -2, and it's 4. Okay, it is going to be decay, and if we look, I kind of wrote that in the wrong order. It's technically being multiplied by 1. What is the y-intercept of the graph? It's going to be 1. I wrote that in the wrong order. So let's do -2, and it's going to be 4. -1, and it's going to be 2. And 0, and it's going to be 1. So what's happening is it's multiplying by 1/2 each time. I wrote it in the wrong order originally, sorry. So -2 is 4, -1 is 2, and 0 is 1. It's multiplying by 1/2. So our common ratio is 1/2. Our equation is going to be y equals 1 to the 1/2 and x, or initial value. Oh my goodness, initial value, common ratio. Whew, sorry, tongue twister. Okay, so here, is it growth or decay? Well, we look here, and we see that it's growth, because that initial value, oh my goodness, common ratio is greater than 1, so growth. And then it says horizontal asymptote. Okay. Well, notice there's nothing being added or subtracted here. So it's technically plus or minus 0. So that's going to be 0. I'm going to go ahead and I'm going to take this line because it says graph it to, and graph it right there. My domain. Well, let's go ahead and graph it first, and then we'll figure out our domain. Well, 3 to the -2 is going to be 1 over 9, right? Because it's like 3 to the negative 2. Well, I got to move it down. So 1 over 3 to the second. Then I actually simplify it. 1 over 9. To the negative 1 is going to be 1/3. Anything to the 0 power is 1. 3 to the first power is 3. And then 3 squared is 9. So I'm going to go ahead and do my best to graph these, which is going to be tricky because those first few are really small points. 0 is 1, and over 1 up 3, and over 2 up 9. So there is my graph. My domain, I run into an arrow pointing in a negative direction, so negative infinity. I follow it over, and it's pointing upward in a positive direction forever and ever, positive infinity. Okay, range, start at the bottom. Well, it's going to be 0, comma, infinity, because it's going to go on forever and ever and ever. My y-intercept, right where that crosses my y-axis, is at 1. Okay, next one, just like this. Oh. Here we go, is gonna be, well, first of all, we're gonna look at our common ratio, and it's 1/4, which is less than 1, so this is gonna be decay. And my horizontal asymptote, if I see, it's actually gonna be, since this is 2, I'm gonna graph that y equals 2 line. And I know that my asymptote, my graph is not going to go past that. So 2, because I look right here. What is my constant? Right, my domain, well, hopefully by now you're realizing that it's always all real numbers, negative infinity and positive infinity. And we're going to start graphing some of these bad boys. So 1/4 to the negative 2 is 16, but then you add the 2 and you get 18. All right, negative 1 is going to be 4, plus 2 is 6, 0. Anything to the 0 power is 1. 1 plus 2 is 3. And you guys can plug these into your calculators, or I can show you. This is where things get a little tricky. When I plug that in, when I plug in 1, I get 2 to the 1/4. When I plug in 2, I get 2 to the 1/16. So I'm going to do my best to try and graph these. And I'm going to start with negative 2, and that's going to be like way up here, because it doesn't quite go to 18. Negative 1 is going to be 6, 0 is going to be 3, 1 is going to be like 2 1/4, and like that. So I'm going to have a graph that's going downward, right? It's going to go down, 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 decay. All right, so my range is going to be 2, and then all the way to infinity. And my y-intercept is technically 3, right? Right where it hits the y-axis. Okay, so now we're on to our Lewis deposits. Okay, so we're going to figure out this is going to be exponential growth, exponential decay, and when we compound something. So this is when we need to look for the word compound. So Lewis deposits $2,150 in an account that yields 7.5% interest annually. So just once a year, it's not compounded. And the time frame is 20 years. So he's gaining interest, which means we're going to do 2,150 times 1 plus 0.075, right? Or rate. It's an R for rate. And then for 20 years. We're going to plug that into our calculator. We're going to make sure we write this. And he is going to have approximately $9,132.88 if he does not touch it after 20 years. That's actually a pretty good return for such a small amount of money. Imagine if you had $1 million. The goal is to never touch the principal, right? Your initial amount. Okay, about depreciate. So we're going to be using this equation because it's going to be losing value every year by 15% due to wear and tear. If the boat is worth $200,000 currently, how much will it be after 5 years? So 5 years. All right, it's not compounding, so that's why we are only using this one. We're going to take our initial amount, 200,000. We're going to multiply it by 1 plus 0.15. Not plus, minus. And raise it to the 5th. All right, that is going to be $88,741.06. And again, I'm just plugging this into the calculator, but I am writing the equation so I can get some credit if I mess up here. But just think, like, if it's depreciating, I want it to be less. Is it less? Yes, it is. Okay, the current recycling plant, or the recycling plant currently has 80 employees. All right, so 80 employees, this is people, so remember, we got to keep it in terms of wholes. It grows by 8.5% every year. How many employees will be at the plant after 12 years? All right, so it's growing. It's getting bigger. We're going to use this one. It's not compounding anything. So I'm going to say 80 times 1 plus 0.085 to the 12th. And when I plug that in, it's going to be approximately 213 employees. All right. Don't give me a decimal because you can't have part of a person. Nobody wants just an extra hand hanging around, even though it is spooky season. Okay, Lila puts $13,000 in the bank that earns 6% interest compounded. Oh, there's that word. That means we're going to be using this equation. How much money will be in the account after 8 years? So our initial amount, our principal, 13,000 plus 1 plus 0.06 over compounded monthly, so 12 to the 8 years times 12, which is technically 96 when I simplify that. When I plug that in, that's going to be $20,000, 983 and 85 cents. Not too bad for 8 years. Imagine if you had more. All right, guys, that's it. Hopefully if you have any questions, let me know, and good luck.